Today we're going to talk about domain. We're also going to talk a little bit about range just so you can see the differences between them. You have talked about domain and range in Algebra 1 and Algebra 2. So a reminder, domain are all the x values. We typically order those least to greatest, not repeating. Range, on the other hand, are the y values, typically ordered least to greatest. X values we like to call input values, and range values are the y values we like to call the output values as well. So we're only really going to talk about domain today, but in future lessons, we're all going to talk about domain and range, like the domain and range of a graph and such. But for now, we're just going to find the domains of certain things. So, for example, find the domain and range of this set of coordinate points. So every coordinate point is x comma y. So we're only concerned with domain. We're only worried about the x values here. So I'm only worried about these guys, so -4 and 0 and -10 and 0 as well. And so we order these least to greatest. So when I write what the domain is, I'm just going to say it's the set of these. So I've got -4, 0, -10, 0. So I'm going to order those least to greatest. So -10, -4, and then 0. I'm not going to repeat that one. So that's my domain, just -10 and -4 and 0. If you do a table, it'd be the same thing. You'd look for the input side of that table or the x values of them and do the same thing, order least to greatest, don't repeat. Now, if it's an actual equation, sometimes I have issues. Most quadratics and cubics and linear functions, those types of things, any of those that we call continuous, which means if I looked at the graph, if they didn't stop or have holes in them, it just kept on going up and down, those domains are going to be all real numbers. And in this case, this is a quadratic. If you look at this on the graph, it would be some U-shaped curve. You can do that on Desmos or any graphing utility that you have. Either way, we would say that these are all real numbers. Now, what all real numbers means, all real numbers is essentially saying any value of x is okay. There's none that's going to cause any issue. Now, the two main issues that we typically see are we know we can't divide by 0, and we also can't have a negative number to take the square root of that because we're talking, imaginary complex numbers in that case. So, speaking of which, we have a couple issues here. So in example C, I have x minus 5. We know that when I have 4 up here, I can't divide by 0. So we need to say, well, what value of x would make the denominator 0? So some of you can say, well, if I take something minus 5 to get 0, that would be 5. So we know x can't equal 5. So I agree. So we know that it can't be. It can be anything other than that except x can't equal 5. Another way you could do it is you could set the denominator equal to 0, or basically say, so if I set this and I want to say what value would give that to me, and then I know, of course, I can simply add 5 to both sides. That's going to give me 5. But I have to say in that case, hey, x cannot equal 5. So x can equal anything else except it can't equal 5. One way we do that is another way of saying all real numbers is a symbol. So that's the all real number symbol. So this is basically saying it can be anything except it can't equal -5. And if you put just x can't equal can't equal +5, if you just say x can't equal 5, that's fine too. Example D, we know down here this cannot be negative. So we have to write that and say, well, I know that 4 minus 3x not equaling 0 means not equaling negative means it needs to be bigger than 0, or equaling 0 is okay. You can take the square root of 0. But then I have to solve that. So if I go ahead and solve that and I subtract 4, I get -3x greater than or equal to 0 minus 4. In this case, is going to give me a -4. Now to solve this, I would have to divide both sides by -3. And we've learned in algebra that when you divide an inequality by a negative number, so if I divide both sides by that -3, it's going to flip my inequality. And then this would give me a positive 4/3. That means that any x value, as long as it's smaller than 4/3 or 1 1/3 or 1.3 repeating, it's okay. But if it's anything bigger than that, like 0, 0 would not work, because if I plug 0 in here, in this case, 0 would be fine because that would be that. But if I pick something bigger than that, then that would not work. So, for example, how about 2? 0, 0 is okay because 0 is between there, or 0 is less than 4/3. But if I plug in 2, for example, try it again. 4 minus 3 times 2. So if I take this -3 times 2, that's a -6. 4 minus 6 gives you a -2. You can't take the square root of that. If I plug in 0, like I was saying before, I would get 4 minus 3 times 0. 3 times 0 is 0. 4 minus 0 is 4. So I do get the square root of 4. That is okay. So in this case, so that does work. And that's why checking your answers can't correct any issues. So that would work there. Another example is this one. This one looks really complicated, but remember, up top, we're not worried about that equaling 0. We just know we can't divide by 0. So I just basically need to take that top portion and say, well, x squared minus 7x plus 10 equals, and then 0 here. So I have to solve this quadratic. Well, that's why we learned how to factor. So this is one of the quicker factoring ones, where in this case, it's going to multiply to a positive 10, and it's going to add up to a negative 7. So if in this case, if it's multiplying with positive and adding the negative, they both have to be negative. So it could be a negative 1 and a negative 10, or it could be a negative 2 and a negative 5. And those are our two numbers that we want. So when I go to factor, x minus 2, x, and then minus 5 equals 0. We can set each of these equal to 0. Set this equal to 0. And if I add 2 to both sides, I know that's just going to change my sign. So I get 2, and add 5 to that, that's going to give me 5. Now, the other thing is it can't equal that. So we know it could be anything other than 2 and 5. So it could be 0, it could be negative 10, negative 6, it could be 1, it could be 17, it could be 1 billion, it could be pi. Any of those are okay so long as it's not 2 and 5.